Prove that root 2 is an irrational number. This is a traditional question. You practice it 2 or 3 times, then it can be done. It is root 2 is an irrational number. We will prove it by the method of contradiction. Always first assume root 2 is a rational number. If root 2 is a rational number, we can write it as p by q, where q not equal to 0 and p and q are co-primes. And they are integers. P and q are co-primes and p and q are integers. Now squaring both the sides, we will get 2 is equal to, that is root 2 whole square is equal to p by q whole square, or 2 is equal to p square by q square. So we can write this as p square is equal to 2q square. As 2 is multiplied with q square, so 2 is a factor of p square. 2 is a factor of p square, which implies that 2 is also a factor of p. Now, if we can prove that 2 is also a factor of q, then they will not be co-primes. Now, you write p is equal to 2k, because 2 is a factor, so 2 into some constant will be equal to p. If we are squaring it, by squaring, we will get p square is equal to 4k square. Now, already we got here p square is equal to 2q square. Now, if we put the values, we will get 2q square is equal to 4k square, or q square, if we will divide to both the sides, then it will be equal to 2k square. That means 2 is multiplied with k square, which is equal to q square. So 2 is a factor of q square. This implies 2 is a factor of q square. So 2 is also a factor of q. Now, both p and q have the common factor 2. That means p and q have a common factor which is 2. Hence, they are not co-primes. So our assumption is wrong. They are not co-prime numbers, but we assume that p and q are co-primes. So our assumption is wrong, So by method of contradiction, we can tell root 2 is not a rational number, or is an irrational number. It is proved.